Okay, we're going to continue on and talk about the cosine graph. So the same rules apply with the cosine graph. We again have our angles in degrees as well as radians. And again, we're doing the increments of 30 degrees or increments of pi over 6 on our x-axis here. So the setup here is very much the same. I also want to make sure that I have my unit circle, my really badly drawn unit circle, but let me actually redraw that because that's really bad. Okay, let's do that again. So we have our, here we go, that's a little better. And we have our, okay, so that's a little bit better. Our unit circle, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, now remember with the unit circle, the x-coordinates of the points on the unit circle represent the cosine of the angle. So, at 0 degrees, the cosine is 1, right, because I'm using the x-coordinates. At pi over 2, cosine is 0. At pi, cosine is negative 1. At 3 pi over 2, cosine is 0. And at 2 pi, we are back at 1. Okay, so those are our quadrantal angles. Again, we want to make sure that we have our special right triangles. So we have our 30, 60, 90 triangle. And if this is 30 here, then I have 1, 2, and root 3. Okay, so the cosine, the other thing we need here is ASTC. Okay, so those are the things we need to help us get all these values. The cosine of 30, cosine is root 3 over 2. We figured out the last time root 3 over 2 is a decimal, is 0.87. The cosine of 60 then would be 1/2 or 0.5. And back at 0. Now I'm in the second quadrant. In the second quadrant, cosine is negative. Okay, so I know this is going to be negative and this is going to be negative. So let's see. The reference angle here is 60 because I'm 60 degrees away from the x-axis, or 60 degrees from 180. So I'm going with the cosine of 60, so that would be negative 0.5. This would be negative 0.87, right? Because this reference angle is 30 degrees. At 180, we're right at the x-axis, so when I get to 210 and 240, those are in the third quadrant, and I'm negative in the third quadrant, so both of those values will be negative. At 210 degrees, my reference angle is 30, so that would be negative 0.87. And at 240, I'll be at negative 0.5, and then back at 0. At 270 degrees, or at 3 pi over 2. And now I'm in the fourth quadrant. Cosine is positive in the fourth, so my last two values here will be positive. 300 degrees, my reference angle is 60. I'm going to be positive 0.5, and I'm going to be at positive 0.87 for my last value. Okay, so I'm going to go ahead and plot those values. So I'm at 1, and then I'm at 0.87, and then I'm at 0.5, and then I'm at 0, 0.5, 0.87, 1, or excuse me, negative 1, back to 0. And another thing, once you do these enough times, you're not going to have to draw in this chart. This is just to sort of first for you to see what the graphs look like and where they come from. Again, this is going to be a nice smooth curve. This shouldn't be like it shouldn't look like a V. It should be a nice smooth curve that comes around, down, comes back up, and curves. Okay, again, like the sine graph, we can carry this across the y-axis here. So our graph would then end up doing this. And it should look somewhat symmetrical. My graphs never come out all that great, but it's a little bit better. Sort of more kind of like that. So kind of more along those lines there. Okay, so that's got a nice little kind of a curve, a nice little curve to it. So that is your cosine graph. It looks similar to sine, but look, it's just a little bit off, right? Our sine graph went through the origin. Our cosine graph doesn't. It's at 0, 1. Okay, but on the bottom of your note sheet, again, we have some properties, and you'll notice that these are basically all of the exact same properties that we had for sine. Okay, so the way you go about doing it is the same. The only things that are different are where it's positive and negative and where it's increasing and decreasing, but you can tell that from the graph. We also know the values of our quadrantal angles. Again, our maximum is at 1, our minimum is at -1. It does go on and on forever. Okay, so it is a continuous function, so my domain is all real numbers, where my range is from -1 to 1. It doesn't go past that. Our period is 2 pi. Again, it takes 2 pi radians to complete one cycle. If you think of a cycle, the cycle would be from here to here, right? That's where it goes and it comes back to 0, and then that repeats again as you go. So this is one cycle. Okay, we'll get into that more, like I said, when we talk about period. Translational symmetry, that has to do with the period. Again, we'll get into that as we get into the whole topic of period and amplitude and frequency and all of those things. And it's a function, but it is not a one-to-one function. Okay, so those are the characteristics of the cosine graph. Like I said, it's similar to sine in that the domain and range, it's continuous and those types of things. But your values are slightly different. They're slightly off, but it has the same, kind of the same look and feel as the graph of the sine function. I want you to get used to these. I want you to get comfortable with these. You will get to a point where you won't need to be plotting every single value in there. What you're going to end up doing is this. You're going to say, all right, well, here is my axes. I have pi over 2, pi, let me extend this, 3 pi over 2, and 2 pi. And you'll say, oh, here's 1, here's a -1, and I know my cosine graph is going to do something like this. And it's going to come back up. Okay, so you're going to get to the point where that's what you're going to do to kind of help you figure out some of these problems. But that's the idea behind this, and that's the general shape of the cosine graph. The last video we did the general shape of the sine graph. As we move on, we're going to talk about different components of this that we can change and how that changes the graph. But for now, I just want you to get the basics of these two down. So hopefully that helps, and we'll see you next time. Thanks, everybody.